So I'm going to bring up our first speaker. So Amanda works at GitLab currently as a developer evangelist. I'm really glad she's starting off the conference because it was actually, we had the idea for this conference while talking to her. I was getting coffee with her, and we were just talking about APIs and a lot of stuff around it. And she just kind of was like, you should have a conference. And I was like, that's a bad idea. And then 6 months or 4 months later or so, here we are. So I'm really excited about Amanda because I've seen different talks she's given. And she is awesome when it comes to talking about APIs and usability and making them easy and easy to use. So without further ado, here's Amanda.
All right, how's everybody doing? All right, got a few woos. That's usually good to see, right? Who's excited about APIs? Okay, got a better response that time. That's really good. So, is this actually changing? Okay, so we're good to go now. So your API is bad, and you should feel bad. But don't worry about that. We can fix it. All things are fixable. So a little bit about me. Who am I to judge you? As Greg said, my name is Amanda Folson. I am a developer advocate at GitLab. And I've been doing this API thing for a while, just sort of on accident. I sort of fell into it. I was making some web apps, and I was like, man, there's really got to be an easier way to do this, right? Turns out there is. You can create an API, and then you don't have to do silly things like scraping HTML to get the information that you want. So me, being a younger developer, I was just captivated by this. I was like, holy crap, I can do this. Someone else has solved this problem for me. So the APIs that I work on range from little dinky things, little tiny microservices, to actually full-fledged DNS management things. I do a little bit of API work at GitLab, but most of the work that I do is actually open source. So as far as APIs are concerned, why should you care about them? Well, APIs are everywhere, and pretty much if you are using any mobile apps from Twitter or Facebook, you're using an API. Those are all API-backed sorts of things. So the idea here, and why you should care, is you're trying to make this consistent. You're trying to create a consistent experience across maybe your web app, as is the case with Facebook or Twitter, and your mobile devices, or anything else you may want to tie into your platform. So the idea here is really to create this API so that people feel like it's part of a contiguous ecosystem. So one of the first mistakes that people make is they're like, all right, I want an API. I'm just going to go build my API. Anybody done that? Yeah, I see a few hands. Yeah, I think we've all been there. You know, it's exciting. You just want to get in there and play with some code. But really, you kind of need to not do that. So let's talk about that for a little bit. In general, I tell people you have to design this first. You can't just walk into a room and start hacking on an API that you expect people to use and expect it to be the most beautiful thing in the world. Really, you need to take time to design these things. So let's talk about that design. A lot of people are really, really irritated by poor design. So what do we mean by poor design? Well, APIs that are maybe usable, but not necessarily the best sort of experience. And it's not that people who are judging these APIs are necessarily design snobs. We just want things to work, and we want things to be wonderful to work with. So we can prevent a lot of these mistakes from occurring in this design phase. Before we even write a single line of code, we can figure out how to design this API, how things should work, what sorts of data should be returned, before we even sit down to write any of this code. So I have an example here. There are plenty of tools that will help you out when you're designing your API, but I actually just wrote this down on paper and showed it to people. So I mentioned a DNS management tool. I run a blacklist for spammers. With mixed results. And so I had to design an API to actually manage the DNSBL side of that thing. So there's several million IPs in there. It gets a little crazy. And an API was the easiest way to manage all that. So I literally wrote this down on paper while I was on a plane, traveling to another talk. And yeah, passed it around. And people were like, oh, you know, this makes sense. Or I'd really like to see this instead. And it actually saved me a lot of time. Because if I had sat down and actually coded this thing, it would have been a piece of crap. So getting that feedback was really, really helpful. And again, you're trying to design a uniform experience. So I already had a web interface for this thing and wanted to create the API so that people could get the information that they needed out of it, could query the DNSBL, get data into the API, get data out of the API, no problem. So your design process really needs to start with sitting down and having a conversation. You need to figure out who this API is actually for, what people can expect out of this API, why would they want to use it, what is the incentive to use this. So it's really important that you involve stakeholders at the start. And stakeholders can be people who are internal to the company, people who are outside of the company, it can be people who are developing open source, it can be realistically anybody. Whoever those people are, they really need to be involved in this discussion because they're going to tell you what they want. And if it's internal, even still, there are always internal stakeholders that you can talk to figure out the best way to design this API to meet their needs. So if you build something people want, they're way more likely to come use your product. If you build something and just kind of toss it out there for people to use, people are probably going to be a little unhappy. And these days, there's a competitor for everything. Yeah, so people will find another API to use if yours is really not going to meet their needs, and that's unfortunate, but it's just kind of the reality of how this works. So today I'm going to be talking a little bit about REST. There are numerous types of APIs, but REST is really rapidly gaining adoption, and a lot of people are migrating some of their older APIs, or even just older apps that required you to scrape HTML to get information, to REST. So REST is usually HTTP based. Doesn't always have to be, but that's what most people are going to be using it for. So you can use action verbs that are found in the HTTP standard. It's pretty straightforward. And it's also nice because you can return pretty much whatever you want. So JSON's really popular, but I see people returning XML even with REST. I've seen some YAML. YAML is gaining adoption as a content type. So that's happening. That's totally something that you can do with REST. You can return all of the above, you can return one, you can accept JSON and return YAML. That's a real thing, people are absolutely doing that. So REST is really, really flexible and it's pretty easy to understand. So as far as the API side goes, regardless of whether you're doing REST or not, APIs have this concept of resources. So a resource is really just a gateway into an area of your application. And, for example, you might have users or places. This just died. Okay, still up there, so we're good. So you might have users, you might have places, things like that, messages. And you can perform CRUD actions. So you can create new things, you can create a new user, you can create a new message, delete messages, and so on and so forth. So when you're designing these endpoints and looking at these resources, in general, I tell people to use plural nouns when working with these things. You might update a single record as part of a resource, or you might be working with an entire collection of things. So in general, it just sort of tends to make sense to use plural nouns when designing your API. However, there really is no standard to this, so there might be times when it makes sense to use a singular noun. So in the case of a shopping cart, you could have a cart endpoint, because a customer is probably not going to have multiple carts. But if they do, that might be a time to evaluate how many carts someone's going to have and whether or not it makes sense to actually use a plural noun in that case. So you're really trying to avoid situations like this. That's not changing. Okay, we're good. So trying to avoid this and catch some of these errors before they actually occur. So sometimes the endpoints just don't make any sense. And if you sit down and actually write this down on paper, hopefully you'll see, wait a minute, this doesn't actually make a whole lot of sense. So here we have this users endpoint, and then we have this orders endpoint. So you hit users, and then you can see their orders, and then there's an orders endpoint, and you pass in the order number, and then you can see that order number, which is owned by that user. Well, that's okay, but it required 2 calls in order to get the information that I wanted. I wanted to see the orders, and then I wanted to do something with that order. So we could have easily done something like users/ID/orders. I already knew the user ID. I didn't need to look up more information. I already had that. So then we could easily do users/ID/orders/order ID. So you still have 2 calls, but it logically makes more sense. They're logically grouped. So it could have been a lot cleaner. This would be an example of using a sub-resource. So users own orders. You're never going to have an order by itself that's not owned by a user. So this is a case where you could have easily made orders a sub-resource of users. So I've also run into endpoints that just have inconsistent data. So the example that I saw was we had creation_date and created-date. Now they're the same information, but they're two different things. So creation versus created, and then you have an underscore versus a dash. Pick whatever you want, but just make that consistent across all of your endpoints. These little inconsistencies, they really, really add up over time, and they make it difficult for people to kind of self-discover your API on their own. A lot of the issues I see are actually related to not understanding REST or HTTP in general, particularly action verbs. So if you're designing a REST API, you'll need to understand a little bit about HTTP as well. If you're not designing an HTTP-based API, maybe this isn't as important to you, but for the most part, this is what people are doing. So these just tell the server what action you're intending to take, and then it allows you to take that action with methods that enable you to create, read, update, and delete, and so on. So a lot of people are actually using these incorrectly. And this is probably the most abused one. People use get for everything, which is really more of like an RPC type thing, not necessarily part of a REST API. So a lot of people, everything is a get. So you get in order to update information, and that doesn't necessarily make a lot of sense. So you do this daily by browsing the web. It's pretty straightforward. And typically you want to return 200 OK if everything's OK. It's not always 200 OK, and we'll talk a little bit about that in a second as well. So post is used to create and manipulate data. Pretty straightforward. It relies on a message body to be sent instead of a query strings. Instead of searching for information, you are actually sending information, whether it's XML, JSON, YAML, whatever you want that content type to be. When that happens, you want to return a 201 created. And going back to 200 OK, things are not always 200 OK. If someone has created a resource, it's OK to tell them that. It is 200 OK, but 201 kind of tells them, OK, this was all right, your request was good, and we've actually done something with it. And if you want to be really nice, you should return a URI to that newly created resource so that people can actually do something with it. They created it, so presumably they want to do something with it once that happens, right? And this one gets a little dangerous. So you can use put to actually update a resource, but be aware that this overwrites an existing object with a new one. If one doesn't exist, it will create one. You don't necessarily have to allow this for partial updates, and really try not to use this if you're trying to do partial updates. You have to put every single thing that you want to update in there, whether or not you're actually updating it. So if you have a username that you're not updating it, but you're updating a password or an email address or something via an API, you would have to provide the username, the password, and the email address in order to update something if you were using put. So again, 201 created if you're actually creating a thing. But you can also use patch, and this one's a little safer, particularly if you're just getting started with working on APIs. This one will be a little bit easier to grok, and your users might appreciate this a little bit more because you're kind of saving them from themselves, right? So this only updates the properties that are provided in the call. So with this one, you want to do a 200 OK on a successful update. If nothing changed, it's okay. It's perfectly fine to send out a 304 not modified. And delete's pretty straightforward. It does what you would expect. You don't want to allow this on an entire collection. So you really probably don't want to allow someone to delete all of your users or all of the messages. Now, if you have an admin component to an API, maybe you do want to allow that, but you should absolutely be careful and limit this via ACLs or some sort of token, something that prevents everyone else from obliterating all of the users in your database. So there's a few options you can do once something's deleted. 200 OK is pretty common if the item or the collection happens to be deleted. You can do 204 no content as well if the item or collection was deleted, but there's no body content to send. Just lets the API client know, like, hey, this was good, I did something with it, but I don't have anything for you since the thing's now deleted. If you're working with something like a CDN and you accept the request, but you don't necessarily do anything with it, you can do 202 accepted. So that just lets the client know, like, hey, your request was good, I did something with it, but I'm not going to do the thing that you asked me to do until a little bit later. So it's up to you to figure out how to do that. But just know that 202 accepted is perfectly valid for this too if you are working with CDNs. And this one is kind of overlooked. Not a lot of people talk about options, but the options header is actually really cool. So this is not for interacting with data. All options is doing is informing the client of methods that are available to it. So you can return 200, 204 no content with this one. But really, the purpose of this is to let the API client know what options it has available to it. So if you were working with a single item, you might allow someone to delete that single item. But if you're working with a collection, say you're on your user's endpoint, you might disallow deleting on that entire collection. You wouldn't want them to delete that. So options is just a nice way to tell the client, like, hey, here are these methods that you can use, and this can vary from endpoint to endpoint. So it allows the API client to automatically discover what's available and make decisions based on that information. But not a lot of people are doing this. So if you're designing an API, this is a nice thing to do for people. And I mentioned content types earlier. So you can return more than one. If you design your API right, it's actually pretty trivial to do that. If you want to keep things simple, you can just return whatever they sent you. So if they send you JSON, you can send JSON back. But clients' needs will vary. I worked with a client who was working with an API that I managed on a Cisco switch. And Cisco switches apparently speak XML natively, but they don't speak JSON natively. So we were looking at doing something with some sort of middleware that would translate the JSON that our API was sending into something that his Cisco switch could understand. So this would have been a great case for us to actually allow XML, even though you don't usually see XML with REST APIs, but it's something you can do, and you never know what your clients are going to need, and that one was actually a pretty big client, so we went ahead and just coded in the ability for him to get XML, just to be nice. And you can certainly do that. I mentioned earlier that people are, they're sending JSON and getting back YAML. There's a configuration tool that we have that you send it JSON to create a record, and then it spits out YAML, which is basically a configuration file, and then you can just copy that and do whatever you need to do with it. Perfectly valid. And allowing more than one content type really makes that sort of thing easy, makes your API more flexible and more robust. However, there is an overhead cost associated with this. So if you're going to do this, really the design time is the time to figure that out. If you are trying to do that after the API is already in the wild, you're probably going to have a little bit of a bad time. It's not impossible, it's just engineering overhead. So now on to some really overlooked things. When replying, you want to use the status code to help explain errors. So things like 404 not found, 401 unauthorized, or the 500 series of, well, we broke things, please come back later after we've unbroken things. You also want to send an error message. If you can send information just beyond the status code, that's always going to be a huge win. So bad request isn't as descriptive as bad request, you left out a thing, please provide us that thing so that we can process your request. Something like API key does not have permission to do this thing is better than 403 forbidden alone, right? With those, you want to be a little bit careful because you don't want to release too much information to the client. You just keep security in the back of your mind. Only tell them as much information as they need to know, particularly when it comes to authorization things. But in this case, bad request, not super helpful. Knowing what actually made that request bad, way more helpful to me as an API client. And it prevents me from having to dig through your docs to figure out that magical thing that I accidentally left out. So I mentioned adhering to standards earlier. Unfortunately, there are not too many standards for this other than HTTP. You'll see a bunch of different error codes for different things. The error messages themselves are not really standardized. There are people that are trying to do this, but in general, just be as descriptive as you possibly can while being concise as you possibly can. There are also people who do RPC-like things as part of a REST API. So I've seen shutdown endpoints. People will make a GET request to that, and it'll actually shut down a server or something. Some people, the purists will be like, no, you shouldn't do that. Don't ever do that. But sometimes it really just does not make sense to have a separate RPC server in order to manage things like that. So I'm okay with people putting things like that in their API, but you have to be honest about it. That needs to be in your documentation. You need to be honest that, yeah, this is not super RESTful. It's probably going to behave a little bit differently than the other endpoints that you'd expect. So that's okay. But again, just be honest with yourself and the people using the API. This is actually a pet peeve of mine. There are a lot of people who just return 200 OK for everything. And their logic there is, oh, well, the server saw your request, so that's 200 OK. But they'll do 200 OK with an error. And, well, that's not really OK, right? So it really shouldn't be used for every single request. And this is probably the #1 mistake that I see is people using 200 OK for everything. Well, it's really not 200 OK. So stop using 200 OK when a resource isn't found. There's a cool little code called 404 that's really awesome for stuff like that and way more descriptive than 200 OK. So also, people who just throw errors that say error. Well, that's not amazingly helpful. Yeah, that happens. And I'm like, all right, well, what's the error? Is it something that I broke? Is it something you broke? I've seen a 200 OK status code returned for the server actually having a 500 error. So I got a 200 OK, a message that just said error. Turns out it was something that was broken on their end, but I thought it was something that I broke. So I had to go back and forth with their support team. It was just a mess. And that all could have been prevented by just adhering to this little thing. So stop returning 200 OK for everything if everything is not OK, please. And it prevents me from having to poke you to figure out what actually broke. So there are best practices for status codes, but like I said, this is not super standardized. People have different opinions on how to do all of this. So in general, really just you need to use your best judgment. You're going to figure out what the best code is for you, what the best sort of error message is for you. But just be consistent, be transparent about it. These codes really need to make it into your documentation. Hopefully you have documentation, right? Yeah, okay. I saw some people shaking their head no, and I'm like, well, yeah, that's common too. So, a case where I mentioned 200 OK in the case of delete operations, and that's a great example of not necessarily having a standardization. So you can do 200 OK. You can do 204 as well. There are some people that do 404. I tend to not like that because it's hard to determine if the 404 is because the thing that I'm trying to delete doesn't exist or because the thing that I deleted now doesn't exist and I'm getting a 404 because of that. It's really hard to determine. Some people just don't care because the thing doesn't exist, so why does it matter? You know, it doesn't matter if it didn't exist before or if it did exist and got deleted. The end result is that you don't want it to be there, and that's perfectly fine. So there are a lot of opinions on how to do these things, and there's no one single source of truth just yet. There are people who are trying to work on that. So one of the other cool things about REST is this concept called Hagios, and it sounds scary, but it just means hypermedia as the engine of application state. That's a lot of words to say. So every object in the API has actions that can be performed on it, and Hagios just helps API clients navigate through that. So you can sort of think of this as links on a page that allow you to delete things or work with the API in another way, particularly if you are on a single record. It tells you, okay, well, you can delete this, but you can't update this, just as an example. So the client is still responsible for tracking the state of these things, but this really just tells that API client, hey, here are the options that are available to you. This is really, really hard to do, but if it's something you want to do, putting it down on paper before you actually attempt to code it will help you out a lot. You can figure out what endpoints will allow which resources, and that's great. Or which resources will allow which methods, sorry. And that's great. It helps you figure out, okay, well, logically, I don't want people to run delete on this collection, or I don't want people to be able to delete this specific record. I want people to do that another way. So people are going to hard code things anyway. That's just the reality of working with APIs, but you can help them help themselves a little bit by doing this. People often overlook caching too. That's something that's perfectly reasonable to do in an API. So telling the API clients to cache things on their end will actually help you scale out your API, particularly if there's data that really doesn't change that often, but that's getting pinged. So I see people that have an API version, they'll return an API version. That's something that you can probably cache for a little bit. You know, it's not super important that people get the most up-to-date version information. They can probably cache that for a little while. Let's talk about authentication. In general, I mean, really, this could be its own talk, but I tell people, kill off basic auth. People do all sorts of really silly things with their usernames and passwords, and you just kind of help them save them from themselves a little bit. If you want to get started with authentication, you can take a look at something like OAuth. It's not necessarily the friendliest thing as far as making CLI clients and things like that, but it's a great way to start. So definitely take a look at that if you'd like. Let's talk about security for a second. So you always want to treat your users as hostile. You really never want to rely on a single method of security either, apply it in layers. I mentioned that I run a DNSBL. I actually query that DNSBL to see if nefarious IPs are trying to make hits to my API. So that's something you can take a look at. You might want to look at expiring tokens as well, or things that require people to actively manage their credentials instead of just having a username and a password that they're never going to change. People also do strange things, like not using SSL. It's 2017. Why aren't you using SSL? Let's Encrypt makes that super, super easy to do. People also still do this. It's 2017, and in 2017, we know better than to roll our own crypto, right? Right? People aren't really agreeing. That's scary. Well, most of us know that. And in 2017, we also know the SQL injection is still a thing that we need to be worried about when it comes to APIs. So you never know where that data is going to be used. So if you are allowing people to just send you some JavaScript and you're just storing JavaScript, that's something that could realistically end up in someone else's website. So you still need to worry about sanitizing the information that you receive. So seriously, use SSL, stop rolling your own crypto, and hire consultants if needed. It might save you money in the long run. It might be a huge upfront cost, but if your stuff isn't getting owned, then maybe it pays off, right? So now what? Beyond designing the API itself, you've deployed, you've designed the thing. Just remember, the API is an ecosystem, and it's not just a set of endpoints that you put out there. So as a PHP developer, this is actually one of my favorite images. It's a double claw hammer that says PHP. So people need tooling. Give them the tooling around the API to help them succeed. So SDKs, sample code, documentation, they need all of that in order to actually be able to use your API. If you can't provide full-featured SDKs, then just little sample libraries will do a lot. I put sandboxes on here. That's a nice to have. I don't necessarily consider it a requirement, but it's great if people can actually play around with your API. If you don't want to do the full-fledged sandbox thing, then at least allow some dummy data, you know, a dummy username, a dummy address, things like that. Put that in your documentation so that people can actually play around with that API without racking up a bunch of charges to do so. And also tell me where I can get help. You know, if I'm stuck, I really, really want to know where I can find humans to talk to, whether that's on a forum, whether that's calling you, emailing you, I don't care. Just make it obvious where I can go to actually do that. And documentation, probably the bane of most developers' existence, right? So it's really, really important. And a lot of the things that I see regarding documentation are that they're out of date, it's incomplete, or it's just not useful. People will leave out entire endpoints of their API, or they'll just put, here's this endpoint, here's the things that it accepts. You have no information about the error messages you can expect to receive. Sometimes you don't even have information about what data you actually need to send in order to do information with that. So most of the problems I see with documentation are that it's out of date or just completely inaccurate. People will update their API and the documentation just kind of falls to the wayside. So something else you need to do when designing your API is plan to maintain it. So in addition to just maintaining the code, you need to look at maintaining the libraries, maintaining the documentation. Be sure to allocate resources to this. This really, really needs to go into your launch plan. Figure out if support is going to be a community thing, is it going to be a paid service, is it going to be something that you do? Doesn't matter to me, just figure out how people are going to get help and tell them where to do it. So if you're looking to prototype an API, there are a bunch of things out there that will help you do it. I'm a PHP developer, so I like using Laravel and Lumen, but pretty much every language has a framework that it can use, that you can use to spin up an API in about an hour worth of work. If you're just looking to prototype quickly without writing code, there's a bunch of spec tools that are available, Apiary, Mockable, Raml. Some frameworks allow importing of these specs. I also use tools like Postman. Postman's great. It allows me to kind of tinker with an API without having to write like a full library. It allows me to update things and just play around. So your API is bad and you should feel bad, but hopefully by now there's a little bit of hope that you can actually fix some of these errors. If you are planning an API, hopefully you can incorporate some of these things into your new API, and then it won't suck. So that's all I have for you. Thank you so much.